I'm going to do an example chemistry or IPC lesson for you today, but I don't have any electronic stuff and I don't have a printer or anything. So if you could just pretend that these are my screen share slides, that's what I'm going to use. So here we go. Good morning. Today you guys are going to need your periodic table, and you may or may not want a calculator. We're going to do some adding and subtracting today. So if you could make sure you get those things, and then you'll need just something to write with and on your notebook. Okay. All right, so today's lesson, we're going to be using our periodic table, and we would like you to be able to determine the protons, neutrons, and electrons in an atom of any element by using that periodic table. And so that's what we're going to do today for our lesson. And by the end of the lesson, hopefully you can be able to do that. Just a couple of things we're going to review from last week is protons are positive and neutrons are neutral, meaning that they don't have any charge, positive or negative. And those are both in the nucleus of the atom, the center nucleus of the atom. And electrons are negative. So hopefully you remember the charges of the different parts of the atom. Also, last week we talked about ions. Remember that an ion has an overall or a net positive or negative charge because that means the protons and the electrons aren't equal. So if it has more protons, it's going to be a positive ion. That's a cation. If it has more electrons, it's going to be a negative ion. That's also called an anion. So we learned that vocabulary last week. And I would like you guys to start today with your partner. I want you to do these problems real quick. Tell me how many protons and electrons these ions would have. And this is where I would partner them up depending on how easy it is to partner them up. I might already have pre-made partners, or I might partner them kind of on the fly depending on who I feel like did the best on the previous lesson. I might partner up the people who were struggling with the ion lesson and then kind of work with them. And so we're going to do that warm up, and we'll go over the answers and talk about how this one has one more proton. That's why it has a positive 1 charge. This one has 2 more protons. That's why it has a positive 2 charge. And the chlorine has 1 extra electron, so it has a negative charge. And so then we're going to jump into the lesson. So I'll ask them to go ahead and draw out a nucleus of an atom. And I want you to put in 6 protons and 6 neutrons in the nucleus of the atom. And so they're going to draw that. And then I would draw on the screen with them. And then also indicate that there's 6 electrons on the outside. And we're going to talk about what atom that might be. And so we've already gone over ions and stuff. So we're going to kind of ignore most of the electron stuff today. And so the first thing I'm going to have them talk about is the atomic mass. The mass of an atom is called the atomic mass. And so really, since electrons are so tiny compared to the protons and neutrons, the atomic mass of an atom is always in the nucleus. We don't even count the electrons. The atomic mass is all in the nucleus. So write that down for me next to your atom drawing. So we're really just looking at our positives and our neutrals, our protons and our neutrons in our nucleus. That's what makes up the atomic mass. So we're going to write this little formula here. Atomic mass equals the protons plus the neutrons. So write that formula out for me and put it in a box. That's important. Atomic mass equals the protons plus the neutrons. That's the main part of today. And so you might already know, if it has 6 protons, that the atom we just drew was carbon. So this is the square for carbon on your periodic table. And go ahead and sketch that out, and we're going to talk about what the different parts of each element on the periodic table tell you. So the top number there, the 6 on top of the carbon, is called the atomic number. And it basically just tells you the protons. For every carbon atom, everywhere, any kind of carbon atom has 6 protons. If it doesn't have 6 protons, it's not carbon. And if it has 6 protons, it has to be carbon. And then the bottom number here is called the atomic mass. And this is actually the average of all the masses of all the different types of carbon that exist naturally. And we call those different types isotopes. We'll get into that in just a second. So you can see it's close to 12, 12.011, but it's not exactly 12. And that's because most of the carbon that occurs, it has a mass of 12. So its nucleus has 12 particles, which would be the 6 protons and the 6 neutrons that we drew up here. But occasionally we get a type or an isotope of carbon that has more than 6 neutrons. Remember, it can't have more than 6 protons because then it wouldn't be carbon. So that's why the number here is a little bit higher than 12. And we're going to talk now about what isotopes are. Okay. So if I was going to just figure out how many neutrons it had, because what if we didn't draw this drawing up here? I would say I'm going to take my average atomic mass, I'm going to round it to the closest whole number, so 12, and then I'm going to subtract the protons out of that, and that would leave me with how many neutrons we have. So to find the neutrons, we just do the opposite of that other formula we wrote down previously. We just take the average atomic mass, round it to a whole number, and then subtract out the number of protons, which is the atomic number. So it's really just the bottom number on each element square minus the top number, and that will give you your neutrons. Okay. We're also going to talk about isotopes. Isotopes, I said a second ago, it's just like different types of the same element. So atoms of the same element with different masses, which means they have different numbers of neutrons. And we're going to talk more about that in a little bit, but before we do that, I want you to get with your partner and do these 3 practice questions. I want to know how many protons and neutrons does the most neutral isotope of each of these elements have. So you're going to have to do what we talked about, rounding to the nearest whole number on your periodic table, and then subtract out to figure out your neutrons. So get with your partner, discuss these 3, see if you can come to an agreement on an answer, and then type it in the chat or show me your answers. And so this is where I would gauge sort of how they're doing. Once again, if possible, I would put maybe the lower level students together, the ones that I expect to struggle the most, and then jump in with them to help them. Or if not, if I need to have prearranged groups, then I would probably just take an advanced level and put them with a mid-level, and then also the lower mid-levels and put those with the kids who I know will struggle. Just depends on how we use the class time. And so we would go over those questions, see how they did. I would ask anyone, maybe if you had a great partner who helped you a lot or really helped you understand, give them a wave or raise your hand to tell me you had a great partner. I don't know how the app works that you guys use. And so we would talk about that. And then we would go on and do some more example questions. So now we're going to talk about different isotopes of the same element. So we talked about carbon earlier, and you guys remember that the atomic mass of carbon on your periodic table was 12.011. And so that's because the most common isotope of carbon is carbon-12, meaning it has a mass of 12 in its nucleus. But another isotope of carbon is called carbon-14. So, and we can write these in shorthand as C12 and C14. So when you see symbols like this with a number next to it, it's telling you the mass, the nucleus. That is the protons plus the neutrons. So we know, since we know carbon has 6 protons, we know both of these would have 6 protons. And then we just have to figure out, okay, how many neutrons would they have to get these masses? So the carbon-12 isotope would be the one we just did. It's the most common one. So 12 minus the 6 protons leaves me with 6 neutrons. And the carbon-14 isotope, if I have a total mass of 14, 6 of those in the nucleus are my protons. 14 minus 6 gives me 8 neutrons in my nucleus. And so that would be the difference between carbon-12 and carbon-14. So take a minute and see if you can do these other 2. You can type your answer in the chat and tell me how many neutrons would each isotope of lithium have, and how many neutrons would each isotope of chlorine have. And so I would let them work. And I might reveal the answers slowly after most of them have typed them in, or I might wait until the end, just depending on the makeup of the class. And then we would go over these. I would talk to them again about the average atomic mass. So like the average atomic mass of lithium is 6.9. So we know that lithium-7 is the more common one in nature. And then same thing with the chlorine, we would talk about that. And then anyone who's struggling, I would kind of, once again, I don't know how your program works, but I would try to do a small group with them on the next part. But I would go ahead and say, okay, now you guys are ready to do the practice on your own. And I would give them maybe 12 questions, mixed questions. And I'm big on power of choice. So I would say you can either do all 12 questions or you can do the first 6. And then instead of doing the last 6, you can write me 5 or 6 steps of how do you figure out the number of protons and neutrons that an element has, and what's the difference between the isotopes. So I would give them an assignment that includes a little bit of choice in what they want to do, and then I would probably work one-on-one or 2 or 3-on-1 with any kids who are struggling, just to get them rolling on that formative assignment. And so that's what I would do, and thank you for listening.